Algebra lesson 5-3. What are the two biggest pieces of information needed to write an equation? At this point, we've spent quite a bit of time dealing with input-output tables, then we gradually went into looking at x and y intercepts, and eventually we found that we had a form that we could use for linear equations, y equals mx plus b, also known as slope-intercept form. And the two biggest pieces of information would probably be the slope and the y-intercept. If we had those two pieces, it's actually very easy to make our equation. We substitute the values in for m and b, and y equals mx plus b, and we have what we need. So how many ways can we actually find slope? Well, one of the ways we could find slope is we could have it given to us. I mean, it could be stated. But most of the time it's not going to be given to us, so we could use the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's one of our methods for finding slope. Another method for finding slope is we could count it on a graph. We could count the rise over the run on an actual graph. For the most part, these are our two best chances of finding the slope at this point. Now, it could be given to us, or we could calculate it using two coordinates, or we could plot the two coordinates on a graph and count with our finger rise over run. And how many ways can we find the y-intercept? Well, once again, we could have the y-intercept given to us. That's one method. Or we could substitute, we could plug 0 in for x. Remember, when you're on a graph on the x-axis, if you actually have a 0, then that's going to be somewhere. If you have a 0 for x, you're going to be right in the middle on the y-intercept itself. So 0 for x would give us the y-intercept. We could also look on a graph and see where it crosses. See where the line crosses the y-axis. And we actually have one more method. We could substitute the coordinate x and y and m into y equals mx plus b and solve for b. So we have three methods. We can plug 0 in for x. If we have an equation that allows for that, we can look on a graph and see where it crosses the y-axis, or we could substitute in the coordinate that's given to us and the m. Steps for writing an equation when you're only given 2 points. So up until now we've been given all the information we need. Then we were given a coordinate and a slope, and we were able to figure out what the y-intercept is. Now all we're going to know is 2 points. Any 2 points. It doesn't matter where those 2 points, if they're on the line, then we can actually get the equation from those 2 points. But the first thing we've got to be able to figure out is, what's the slope? So we're going to use the slope formula to figure out what the slope is, because once we know the slope, we can go from there. So this is the only real change at this point. We've got to be able to find the slope. It's not really a change because you know how to do it, but we have to be putting it into what we do. Now you'll notice this is the same as before. After we figured out what the slope is, we take that slope and we plug it in for m. And we choose one of the given points. Remember, you're given 2 coordinates. Pick one. It doesn't matter which one. Yeah, but how come it doesn't? The reason it doesn't matter which one? Because they're both on the same line. If they're both on the same line, it's not going to matter which coordinate you use. It doesn't matter if I go from here and I go up 3 and over 1, or if I go from down here and go up 3 and over 1. It's the same line, so it doesn't matter which coordinate you use. Plug all the values in, m, and then one of the x and the y, and you're right back to solving for b, which means you're going to find your b value, the y-intercept. You won't put anything for x and y. The only difference between what we've done in the past, before we were doing steps 2 and 3, we were given the slope and a coordinate. Now we're just given 2 coordinates that you first have to find the slope and then plug them in. So you're going to get more practice with what you were doing before. Write an equation from the following: -3, 1, and 5, 5. I would label them. So you've got your x sub 1, y sub 1, x sub 2, y sub 2. So you have all your information. You know you're going to use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Make sure you plug stuff in the right locations. It's a very common mistake. People put the x's on top. You should put your y's on top. My y sub 2 value is 5. My y sub 1 value is 1. X sub 2 value is 5. X sub 1 value is -3. Plus the opposite, plus positive. 5 plus -1 is 4. 5 plus 3 is 8. Giving us 1/2. So we have a slope of 1/2. Now it just becomes like the other day. We know we have y equals mx plus b. Choose one of those coordinates. It does not matter which one. Alright, I'm going to use -3, 1. So if I use -3, 1, I'll put a 1 in for y. Put my 1/2 in for my m. I plug -3 in for x. And what I don't know is b. And I'm going to solve for b. If I solve for b, I should multiply these two together first. 1 is now equal to -1.5, because half times -3 is -1.5 plus b. And then to solve for b, I add 1.5 to both sides. And I complete my situation with 2.5 is equal to b. My y-intercept is at 2.5. Final equation, y equals the 1/2 slope x plus 2.5, or 2.5, whichever way you'd like to write it. But let's just say you had chosen the other equations, or the other coordinate, 5, 5. So now 5 is equal to 1/2 times 5 plus b, which means you're going to multiply the two parts here. 5 is equal to 2.5 plus b. So you must add -2.5 to both sides. Final answer, those cancel out. 2.5 is equal to b. What do you know? Exactly the same y-intercept, which is good because it's on the same graph. It better have the same y-intercept. Therefore, y equals 1/2 x plus 2.5. You are not going to have to do it with both coordinates. You simply pick one of the coordinates. First, use the 2 coordinates to find your slope. Then use the slope and one of the coordinates. It doesn't matter which one, but use one of the coordinates to find your b value. Then you can write your equation. I did it both ways so that I could prove that it doesn't matter which coordinate you use. It's up to you. Oops, don't want all that information yet. Perpendicular lines. Now we've talked about parallel lines. Parallel lines have exactly the same slope. So whatever the slope of one line is, the other one that's parallel to it will be exactly the same value. Perpendicular now is a little bit different. They have negative or opposite reciprocal slopes. So if one of the slopes is positive, the other one's going to have to be negative. That's one part. But if one of them is 1/2, the other one's going to be the reciprocal of that, -2/1. So you have to flip it and change the sign. So one line has a slope of 1/2. Then the perpendicular, this is the symbol for perpendicular, the perpendicular line is going to have a slope of -2/1, which could be written as -2. One of them is positive, one of them is negative. This is a reciprocal of this fraction. So they will always be opposite reciprocals. Very common mistake. People remember to flip the two, but they forget to change the signs. Or people remember to flip the sign or change the signs, but forget about the reciprocal piece. All right, last example. We have RFG, F to G is this line right here, and G to H perpendicular. Has nothing to do with writing equations, it has everything to do with looking at the slopes. So let's look at F to G. F to G, the slope is equal to, well, rise, it goes up 2, and run, it goes over 1, 2, 3, 4, 5, 6. So it looks like it has a slope of 2/6, which is equal to 1/3. Now, in order for it to be perpendicular, it's got to be the reciprocal and the opposite. So let's look at G to H. G to H has a slope. This time it goes up 1, 2, 3, 4, 5, 6. So it goes up 6, and it goes left 2, which means it goes up 6 and left 2. That would be negative 3 over 1. They are opposites and they are reciprocals. Therefore, they are perpendicular. Yes, they are going to come together at a 90-degree angle. They are perpendicular. As far as the equations for each one of them, we have the slopes of each line. Now we need the y-intercepts. Not very easy to look at this and say, oh yeah, I know for sure the y-intercept there. That one's not too bad. That's a little bit better. But we're talking about this line and this line, so it doesn't do us any good to know that y-intercept. I need to know where that one's going to cross, and I need to know where that one's going to cross. Fortunately, I have the slopes. I just need one of the coordinates. This coordinate right here at G looks like it's at 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So I could use that coordinate for both of these and write two different equations. So I'm going to use 4, 6 and the two different slopes. So y equals mx plus b. I substituted in 6 for y. My slope for, we'll go ahead and say this is FG. So FG had a slope of positive 1/3 times an x value of 4 plus a b value I don't know. That's going to be 6 equals 4/3 plus b. 6 equals 1 1/3 plus b. So subtract 1 1/3, and you end up with a b value of 4 2/3. So our final equation, y equals the slope of 1/3 x plus 4 2/3. That's the equation for f to g. Now let's look at the graph. 4 2/3. 1, 2, 3, 4, and yeah, that looks like maybe about 2/3, so it seems reasonable. The other equation, which is g to h, y equals mx plus b. Using 4, 6, I'm going to say 6 equals, now this time the slope was negative 3 times the 4 plus b. So 6 equals negative 12 plus b. Add 12, add 12. We end up with 18 is equal to b. So y equals the negative 3x plus 18. Looking at the graph, would it seem like if this kept going it would cross the y-axis at 18? Yes, it seems reasonable.